So our last section in Chapter 8 is 8.7, and it's on dilations. As I said, this is the last transformation that we're going to study. We didn't study it when we did reflections, rotations, or translations, because none of those transformations change the size of a shape. Dilations do. Okay? Dilations are going to create a shape that is similar to the original, not congruent, okay? Similar. So this is not a rigid transformation. Okay? Your pre-image and your image here will not be congruent. They'll be similar. Okay, I also said that a lot of times when people see dilation, they think something getting bigger, like if you have your eyes dilated. Okay? It doesn't necessarily have to get bigger. Dilations can get bigger or they can get smaller. Okay, each dilation, to do it, you have to know two things. Okay, one, you have to know where the center of the dilation is. Okay? And two, you have to know what's the scale factor. Okay, how much bigger or smaller are you making it? Okay, a lot of times the center of the dilation is going to be one of the vertices of the shape we are dilating, usually. So what that means, if you have a point, like these 3 points, and let's say you're going to make a dilation of that shape, and you're going to let this be the center of your dilation, that point won't move. Any point that's at the center of the dilation, it doesn't change where it is. But let's say we doubled the distance from everything else, okay, from that point to the dilation. Okay, so this point would end up here, and this point would end up here. So that triangle in red, that's a dilation of it. Okay, one of the vertices ended up staying right where it was. The other two doubled their distance away from the center of the dilation. Okay, so a dilation that has a center C and a scale factor K maps every point P to a new point P prime, such that if the point you're dilating is not right on the center, then P prime lies on the ray CP. This is the ray CP. If you were to dilate this point, it's got to stay somewhere on that dotted line. If you were to dilate this point, it's got to stay somewhere on that dotted line. Okay? And it also could go smaller towards the center. But the point is, everything kind of stays on those rays. Okay, and then your scale factor is always a positive number. Okay, we're not going to do negative. That wouldn't make sense. We're always going to do positive scale factor. And this is how you find it. To find your scale factor, take the distance from the center of dilation to the new point, divided by the distance from the center of the dilation to the old point. Okay, so in the example I did up above, to find the scale factor, you'd find the distance from the center to that point in red, then find the distance from the center to that point in blue, and divide the two. Let's say the distance in red was 8 units, the distance in blue was 4. 8 divided by 4, that's a 2. That means it's a scale factor of 2 units. Or scale factor of 2, sorry. Twice as big. Why won't your scale factor ever be equal to 1? What would happen if you had something and the scale factor was 1?
And you didn't even enlarge it for 1-to-1, then it's actually like scale model.
Yeah, if your scale factor is equal to 1, then that means you didn't enlarge it, you didn't reduce it, you didn't transform it. It's not a dilation. Okay, and the second fact, I already told you this, if the point that you're dilating is at the center of the dilation, it doesn't move. The original point and the new point are the same. For most dilations, one point will not move. Everything else will. Okay, the dilation is a reduction. Okay, that means it gets smaller. As long as your scale factor is between 0 and 1. Okay? 0.2, 0.7, 0.5, 0.63, any number like that. Between 0 and 1, that scale factor will give you a reduction. If your scale factor is bigger than 1, it's an enlargement. Notice I never said when it equals 1, because it won't. We already said what happens if it equals 1. Okay, so looking at this picture, let's see if we can figure out the scale factor. All right, so C is the center of the dilation. And which one is the original here? Blue or red? Blue. Okay, the way you know the blue is the original, look at the letters. They don't have the primes. Okay. Prime means you've done a transformation to the point. Okay? In this case, all the points moved. Okay, I said a lot of the times one of the points on your shape will be the center of dilation. Well, not this time. All right. So to find the scale factor, take the distance from C to a new point, and then from C to an old point. Well, from C to P prime, it's 3 units. That's the new point. From C to the old point, it was 6 units. What's the scale factor here if you divide 3 by 6? Connor? So keep in mind it got smaller. So it got smaller, so it wouldn't be 2. 1/2. Yep. You take the distance from the center of dilation to the new point, divided by the center of dilation to the old point. You have to do it in that order. Okay? So that's a reduction. Scale factor is 1/2. Okay, any question on that? Okay, you might have done this kind of thing like in art if you draw a 1-point perspective. A lot of times you have a point in the middle, like your vanishing point, and then you draw lines out from that point. And if you were to draw like doors in a hallway doing that, all the doors would look similar. They would be larger and smaller versions of each other. Larger as you get towards the edges of the picture, very small as you get towards the middle. And that's what gives it the illusion of like that vanishing point. Has anybody ever done that in a class, drawn like 1-point perspective? Yeah. Based on this idea. Okay, so here's another one. Identify the dilation. So I'm asking, is it an enlargement or a reduction? And then find the scale factor. Olivia, what kind of dilation is this? An enlargement or reduction? Yeah, it got smaller. Blue is the original, or you could think blue is the pre-image, red is the image. Okay, it got smaller. Now I want to find the scale factor. Justin, how would I find the scale factor here? Wait, can you tell me what numbers I would put?
1/2.
Where do you see the 1?
2/3.
Yeah, 2/3. Yep. Okay, so 2 is the distance from, maybe I could have done it like that, from C to the new point. That goes on top. The distance from C to the old point goes on the bottom. Okay, if you say something's a reduction and you write down a number bigger than 1, something's wrong. Either you did your scale factor wrong, or it's not a reduction, it's an enlargement. Okay, so reduction, it's got to be less than 1. Okay, any questions on that? So that's it. It's a reduction. Scale factor, 2/3. Okay, here's another one. Okay, so it's a dilation. Here's the center. Is that an enlargement or reduction? Sarah? This is an enlargement. Okay, what's my scale factor here? Alyssa? 2/1. The distance from the center to the new point over the distance from the center to the old point. Now, if you had multiple options to pick from, it wouldn't matter which one you pick. You could take the center to any new point divided by the center to any old point, as long as you pick corresponding points. If you pick the top point for the red diamond, pick the top point for the blue diamond. If you pick the left point for the red diamond, pick the left point for the blue diamond. Okay. I don't have multiple measurements here. I have to use the ones they gave me, which is to the top point. That's all that I know. Okay. Any questions on that? All right. All right, so dilations are usually done on a coordinate plane. It makes it easy to measure the distance if it's not given to you, okay, using the distance formula between 2 points. And a convenient place to have the center of dilation is at the origin. Okay. So in a coordinate plane, there's a special property that happens here. Okay, if the dilation, center of dilation, is right at the origin. Okay, and this is basically what happens. If you had a scale factor of k, it's almost like you're putting a k on the outside of these parentheses and distributing it. And that's what's going to happen to all your coordinates. So like, let's say you had a point that was at 3, 4. Okay? And that's part of some shape. Okay? And your scale factor was 2. And the center of dilation was at the origin. Where this point is going to go to would be 6, 8. All you have to do is take the scale factor and multiply it by each x and y value. That's what this is saying. Any question on that? So it makes it very easy to translate points in the plane as long as the center of dilation is at the origin. Just multiply all your x and y values for every coordinate by the scale factor. This doesn't work if the center is not the origin. Does everybody have that? All right, so you don't have to write this all down more. The picture is what's going to be important. Okay. I want to draw a dilation of a rectangle. These are the 4 vertices of the rectangle. We're going to use the origin as the center. And I want to do a scale factor of 1/2. Okay, so this is a reduction. After we do that, I want to look at the perimeter of the original shape and the perimeter of the dilation and compare them. Does anybody have a guess how the perimeter of the dilated image is going to compare to the perimeter of the original based on the scale factor? Yeah?
It'll be
Half. Yeah, it will end up being half as big. Okay. But let's go through it and try it. Okay, first thing I need to do is let's draw the original shape. So we got vertices at, let's see, for the original, what color do we normally use? Is that blue? Yep. So we got 2, 2. We've got 6, 2. We've got 2, 4. 2, and the other one hopefully should be right there. 2, 4, and yep, 6, 4. Yeah. All right, let's label them. It's A. B is 6, 2. Okay, C is 6, 4. And okay, so you got our shape. Connect them, make our rectangle. Okay, let's see if I can I make it all blue? Yep. All right, so there's our original. Okay, first thing I want to do before I even draw it is just figure out the coordinates of A prime, B prime, C prime, D prime. Okay, so based on what I just said, and the scale factor of a half, where do you think A prime is going to end up?
1,
1, 1. Multiply each coordinate by 1/2. Okay, how about B prime? James?
3, 1.
3, 1. Okay, C prime? Jacob?
3, 2.
It's going to be 3, 2. And D prime, last one, that's going to be 1, 2. Now the only reason you can do this little shortcut is because the center of dilation is where? Oh, at the origin. If it wasn't at the origin, this doesn't work. All right, let me make it bigger so we can see it. All right, so A is 1/2, 1/2. A prime. B prime is 3, 3.
Wouldn't it just be 1, 1? So
Yeah. Did I write one? Yeah.
It's 1/2 of 2. That's all
Yeah, 1/2 of 2. I'm sorry.
We're all special.
All right. So yeah, now we're good. A prime is 1, 1. B prime is 3, 1. 1, 2, 3, 1. Double check. Make sure I don't make a mistake again. 3 prime is C prime is 3, 2. It's kind of hard to see, but it's the best we can do. D prime is 1, 2. 1, 2. All right, so let me just sketch that. I can try to label it, but that's A prime, B prime, C prime, D prime. Okay, let's find the perimeter of the original. Okay, so perimeter of ABCD. Since all the sides are straight, it's not turned or anything, you can just count. What's the perimeter of ABCD? Here? 12. 8, 8, 2, 2. So, I'm sorry, 4 and 4 is 8, and 2 and 2 gives me 12. Okay, so there's the perimeter of ABCD. Now our thought, because we did a scale factor of a half, is the new perimeter will be 6. So let's see, perimeter of A prime, B prime, C prime, D prime. Does it come out to 6? What do you think, Alyssa? Yeah. 2 on the bottom, 2 on the top. That's 4, 5, 6. So it turns out that if you do scale something, by k, the perimeter is changed by k. Just take the perimeter, multiply by k.
So we just divide the perimeter by, or multiply by a half.
Yep.
And then you find the perimeter of your new thing, and then you find.
Yep. So if you know the perimeter of the original, and you want to find the perimeter of the new one, just multiply the perimeter by k. Yep. Any question on that? All right. All right, so this is summarizing what we just said. So in example 2, we could see that the ratio of the perimeters, if you took their ratio, it's exactly the same as the scale factor. Okay, we just said that. So the ratio of the perimeters is the same as the scale factor. All right, so in the next one, looking at an example of like a shadow. Right? So there'd be like a light source at point L shining on like this stick figure doll thing, and then there'd be a screen a certain distance behind it. Depending on how close you put the screen to where the object is, that's going to change the size of the shadow. All right. So we know that the shadow puppet, okay, from C to P, that's 12 inches tall. I want to find the height of the shadow. Okay? And I'm going to give you a couple different scenarios. Okay, so the first one, I'm telling you that LC and LP are both 59 inches. And then LS and LH are both 74. Okay, so what do you think you're going to have to do to find the height of the shadow using the information given? Okay, just kind of get a rough idea. I want you guys to try it on your own, and then we'll see if we can figure it out together. Yeah, you're going to have to find the scale factor. Okay, you could almost think of it as triangle LPC and triangle LHS. Okay, find the scale factor between those two triangles. You have enough information to do that. Once you have the scale factor, then all you have to do is look at the original height of the doll, multiply it by the scale factor to get the height of the shadow. Okay, so try that on your own. See if you can find the height of the shadow for part A, and then again for part B. Okay, and then we'll take a look at it. All right, so Luke, how'd you set it up? What'd you do?
I just found out what percent 59 is to 74, because 74 is the total of the entire triangle.
So you found the scale factor first?
Yeah.
All right, so to do that, take 74, divide by 59. Let's see what that give you.
It's 1.254237.
Okay, so let's call it 1.25. That's our scale factor. And what would that be as a percent?
It'd be 125%.
It's 125%. Okay, so there's our percent increase. Now, if you know the height of the original is 12 inches, what did you do to find the height of the shadow?
I multiplied it by 5/4. So 125%.
Now 5/4? Oh, because you just changed it to a fraction?
Yeah.
Okay. Yeah, just take the height of the original, multiply, height of the original, times the scale factor, 1.25. So the height of the shadow in this case would be 15 inches. And this is your scale factor. Okay, scale factor is usually written as a decimal. When you write it as a percent, now it's a percent increase. Okay, so if I ask you for a scale factor on the test, I want a decimal. If I ask you for a percent increase, take that decimal, multiply it, or take that number, move the decimal 2 places to the right. That multiplies it by 100. Okay, how about someone else for part B? How would I get my scale factor there? About Brian?
So you put 66 underneath the 74.
Yep, so 66 would be underneath 74. Divide them out. Let's see what we get. We get about 1.12. That's my scale factor. Okay, compared to part A, is the shadow going to be bigger or smaller? Smaller. Okay. Part A, we scaled it by 1.25. Now we're only scaling by 1.12. Still bigger than 1, so it's going to get a little bigger, but not as much. Okay. Denver, what would this be as a percent? Yep. It's 112%. Okay, now my last step, find the height of the shadow. Okay, we do it exactly the same way we did part A. Take your scale factor, multiply it by 12 inches. So it's going to be 13.44. Oops, inches, sorry. Inches. Okay, any questions on that? Okay, any questions in general on dilations? Relatively easy transformation to work with, and all you have to do most of the time is find a scale factor, sometimes find a perimeter. All right, so for tonight, this will finish up chapter 8 on page 509. Okay, I'd like you to try 8 to 13 all, 16, 20, 24 to 26 all, and 35. Okay, for the MCAS, tonight, I think we said 1 through 6. Okay, so you still got a little bit of time left. You get about 13, 14 minutes. Okay, so please try to get a start on that. And if you get stuck, I'll walk around and help you out.